We're now going to attach our elevons to our wing. The elevons are symmetrical, so either piece can be used on either side, but the control horn goes on the bottom of the wing. You can see this is the top and this is the bottom, because this is the side the servo mounts on. So before doing our servo mount and our linkage, we're going to mount our elevon. You have some pieces of tape here. It's a polyester hinge tape, and you can remove a piece. Do this, clean your hands before you do this, so you have nice clean hands, and then you can apply your tape halfway on one side of the elevon, and another piece on the other side. Just remove the tape from the liner, and stretch it out a little bit with your fingers and apply it halfway on both sides, like so. And now we want to attach it so that we leave a gap here of around 30 thousandths, and you'll have a little bit of a gap on this side as well. Also, you want a small gap in between, but the best way to do that is to pull the elevon at an angle, about a 45-degree angle, the same as your trim, to the edge, and then roll your tape over on both sides. And now we can smooth the tape out, and you see we have a gap there and a gap here, maybe a little less on this side, so when we mount our rudders, it will clear. We might have to trim a little bit off on this side, and that's okay, but we don't want it touching here and interfering with the movement. So we do that for one wing, and we'll do it for the second wing panel. Here's the other elevon. We remove the tape from the liner, take our fingers, stretch it straight, not too much pressure, halfway on. You can lift it if you need to, reapply it. And the second piece, again, same. We're going to hold it on both ends and bend it about a 45 down, leaving this small gap on this side. Doing it this way, leaving it at a 45, make sure that there's enough gap so that when you bend it up, and you are able to fully bend it when it's being controlled. So both pieces have their elevons ready to go, and we can move on to mounting the servo and the linkage. Servos come in lots of flavors these days, and the one I'm using for this plane and the cutouts are designed for is not a smaller one, nor it is a slightly bigger one. It's right in the middle, and it's called the Turnigy TG9Z. And it's a really low-cost servo, and it's good for this job. However, and that fits precisely in here. If you want to use a smaller servo, such as the HTX servos or the micro servos, you'll see that you need to make some adjustments. And this should fit in with some trimming here, because this area here is a little taller, so we might need to trim up a little bit. Also, the physical size of the servo is slightly smaller, so it would wiggle around a little bit, so you might have to put a little thin foam strip or something in there to fill in the gap, so once it's mounted, it mounts securely. However, when you place the servo in, we're going to recommend you put a little of the contact cement on the servo, and so it mounts on the inside of the wing. That may in itself be enough to hold the servo in place, but I like to have them tight, so I would recommend putting a little shim in there. But also, if you have a slightly larger servo, this should work as well. As you can see, this servo is almost identical in size. It'll fit in. It'll fit that way without trimming. However, it's a little taller, so we would have to trim a little bit out here in order to use this servo. We're going to use these, and we're going to hook them up and center them beforehand, because we have to remove and position the control arm properly. We need to get these servos centered beforehand. Installing the servos in the wing, we're going to pre-center these servos by hooking them up to our radio on channel 1 and channel 2. Almost all the receivers, no matter what type they are these days, the ground seems to be on this side of the rather the black wire or the brown wire, depending on whether it's a servo or a power plugging in. That's your negative side, always seems to be towards the right of the plug. If your plug-ins are on the right of the receiver. In the case of this this Turnigy, if I rotate the brown wire here on this end around to that orientation, and the orange wire on the inside, which is your signal wire, the middle wire is red, that's positive power, and then we have negative power, the brown, and then the signal wire is towards the left. On this receiver here, it's similar in that if you turn it right side up here with the connectors on the right side of the receiver, the brown goes down and the orange is up. So we're going to plug both of these servos in on channel 1 and channel 2 with the brown at the bottom and this orange at the top. And the power, likewise, the black is the negative and it's going to go down. We're going to plug this into channel 8. Okay. We're going to turn on our transmitter and we're going to center the controls here. If you have a modern transmitter, this one has a module on the back, so it's a 2.4 gigahertz frequency, and it's also channel hopping, so it's legal these days. And also, but this is an older transmitter that used to have an RF module in the back that was different. But at any rate, this has the old style slides. Okay, so I'll just center those. But if you have the new style, sometimes there's a push button, top or bottom. such as this one, actually the button is you move it up or down. But it will signal you when you're in the center of the travel. So as you go up, that beep is the center of the travel. And now we're going up all the way to the end. That's the end. And then we're going to go down until we hear a beep for the center of the travel. Right there. And you can do that for both sides. We also have this cheaper model, and it has a button. It's kind of a rocker style, and it's moving. I'm at the end of the travel there, and that long beep says I'm in the center. That's the end of that travel, so we're going to go back till we hear the long beep. And then I'm going to go right. I hear the long beep. Either way I push it, that means I'm at the center of the travel. Pushing either side, if I can hear that long beep, I'm at the center. So on this one I have moved my slides or little potentiometer adjustments to the center of the travel, and I've centered the servos. So each wing, there's a left hand and right hand version. So if we orient this servo in this way, you can see this the gear and the output shaft is towards the front of the wing, and on the other side it will be just the opposite. If you put it on backwards, it's not a big big issue. For instance, if I had put this on this way, okay, like this one, okay, just flip it over and change it, but we want the travel vertical. On this we're going to put differential aileron in, but we're going to do that using radio controls themselves, the programmable radio. Differential travel is when there is more travel in one direction than say the other. In this case we're going to adjust it so there's more up and less down. But that'll be done when you program the radio. So at this point, we're going to set up both servos symmetrical to each other with the control horn towards the front of the wing. Okay. And we'll go ahead and tighten down this. Now my radio is energized right now, and so you can't move this unless you strip the servos. So when you're tightening this on, just be careful to hold this and not just hold the servo and tighten down, because you're putting a lot of pressure on those gears. Hold the control arm and then tighten down. Now I like using these little connectors here. Clevis, I don't know what you call this particular part, but the wires that we're going to use, or control linkage here, they slide through like this and are adjustable, and you have a little screw that goes here to tighten it, so you can tighten it in any position you want it. So where I like to put these on this plane is about the third or fourth one up. You see 1, 2, 3, 4. Now the hole in through the servos are often, or the control horn is often too small. So in this case, Well, I have measured this, and it's about 80 thousandths, and I have a bit that's approximately 80 thousandths. You want them to be pretty close so that there's not a lot of looseness in the linkage. So I'm going to go the fourth one up, 1, 2, 3, 4, and I'm going to drill that through. There. So this is actually a little tight. If I push it in, it goes in, but there's a little bit of, there's no slop. It's tight. You don't want it too tight. You want it to move fairly easily, because as the servo moves through its travel, this will rock back and forth. And you want it to be able to rotate freely. So I'll put the drill in there, and I'll just move it around a little, wiggle a little as I'm drilling, just open up a little bit more, and so it goes in nice and easily, it turns, and there's no slop in the system. Okay. This one still needs to be screwed in place. Alright, so both servos are prepared, and I have this one here I'm going to mount here. Which channel this is supposed to be and how it's supposed to be mixed we'll deal with later. Right now we just need 2 independent servos ready to go. So I can shut my radio off, unplug everything, and we can begin working on this wing. So I'm going to put my little piece in here. This one also needs a little loosening up. I'm rocking it back and forth a little bit as I'm drilling, not too much, because you can open it up too much. And then maybe a little more. There we go. So that goes on nicely. This particular one has a thread. If you notice, there is a threaded area, and then there's an area that's just about the thickness of the control horn. So if you tighten this down, it shouldn't put any pressure on the control horn. So we'll take this washer and put it on. And then there's a nut goes on. There's a no lock washer on this, but you can put a drop of cyanacrylate quick glue on it afterwards. So we're going to just tighten this up and make sure it can still move a little. See, it's rotating okay. If I tighten it down, it doesn't want to move, so I'm going to sort of unscrew it until the nut moves. Now it moves. Now I'm going to put a little drop of cyanacrylate on that thread right there to stop the nut from coming off. We don't want to put too much on. I want to make sure this is dropping just the right amount. Okay, so we're ready to go there. And then just going to put a little drop on the threads there. That should hold it. Alright, so we're ready to mount this servo inside, but we need to get our extension inside here. And so we have a servo extension here that we want to thread through. I'm going to use this thin wire as a fishing tool, and I'm going to take my needle nose pliers and just bend a loop back on itself on one end, and then we can fish this through the servo mounting hole all the way through to the other end. And now we're going to pull the end that's just like the servo end. This is a female plug, a male plug. They'll fit together, so we want this to stay here, and we want the male plug end of the extension to go through. So we're going to bend a line here, or bend the wire, like so, and then we'll put this through so we can pull our male end through to the other side. Now we're through. Now we'll attach our servo. In this case, black wire to brown wire, red wire to red wire, white wire to the orange wire. So the darkest wire is always negative, red wire is always positive, and the lightest wire is always the signal wire. Now we don't want these to separate, so when you pull it through, don't pull too hard, just pull lightly, and when we get close, stop pulling, and now we'll be pushing. But we'll take a drop of glue, our tack glue. This glue does not eat in plastic. We'll put a couple of drops here on the servo, a little line, a couple of drops. And then we're going to insert our servo, and we can pull on the line a little bit to pull it a little closer, but don't pull it apart. And then push our servo until it's in contact inside, and our servo is mounted now. Now we can take our control linkage, and the way it's designed is the control linkage will be oriented like so. So you'll put it in from the outside of the wing through the hole in the control horn. It's a good idea to hold the control horn with something while you do this so you don't break the control horn off. So we're applying pressure, and then we're through. Now these pieces should be short enough to insert, but if it's not, you can cut a little off. Don't take too much off, you want some adjustment room. A little bit more. Okay, we got enough off that we can put it inside. Take your pliers here, hold it, and we push it together. Okay, our linkage is through. I'm going to tighten it down and temporarily hold it in place so it doesn't come out. There we go. Found it. So I'm going to adjust it so it's level. Our servo should be centered, so adjust it so it's level here. And tighten so it grips our wire. And so this wing is done. You notice the servo comes through this top surface a little, but it's not critical or a problem. We could have taped this down and temporarily, but I prefer to put a little glue. If you want to put some reinforcing tape, if you like, you can put a little reinforcing tape over. The glue should hold it down, but this is sort of just in case, just a little piece of shipping tape or reinforcing tape. Okay. This wing is ready to go, and we want to repeat this for the second wing. The left wing half. This is the right wing half, so we'll repeat this for the left wing half. Earlier we had installed the servo and the elevons together. Now that this is done for both wings, we're going to apply the rudder that goes on the rear main wing. And the rudder is required to help the plane fly straight and stably. And it corrects yaw conditions, yaw being this turning without turning. It's a sort of, when you create a drag on the wing on more on one side than the other, it will cause the plane to yaw the direction of where the drag is. And when the ailerons, or rather elevons, are operated, there's more drag when the elevon goes down than when it goes up. And that's one of the reasons why we put differential elevon in, is that we wanted to compensate for that so the plane doesn't yaw the wrong direction when turning. Because it wants to, when the elevons are down, it wants to lift the wing and turn towards the left. But because the drag's increased, it causes the plane to yaw in the wrong direction. And that's called adverse yaw. And you can correct a little bit for that by putting more up elevon than down, and that can be built into the radio programming itself. That aids in it turning, not only turning in the right direction, but pointing in the right direction during the turn. It also helps in that when you're turning, you have to have more up elevator, or elevon in this case, on both surfaces of both wings to pull the nose up, because when you turn, you have a loss of lift on one wing. Generally, the overall loss of lift, because your span has decreased because of the angle relative to the ground, is that the plane wants to nose down a little bit, so you pull up elevon. And so having more differential elevon pulling up on one wing and the down on the other wing, or rather down on this wing and down on the other wing, turning left, having more up makes it a little easier to turn. You still have to pull some up elevon during a turn, but not as much if you've added differential control. But now that that's done and the servo's in there, we can place this or glue this in place without worrying about it in the way during the servo installation. And you remember that we should have some gap here and a gap here. We're a little bit off on this side. The gap is a little large on this one, so we're going to cut a little bit extra off here. So I'm just going to turn this over and take a straight edge and maybe trim just a little more off, 20-30 thousandths with the blade, like that. Now when the rudder is in place, there's a gap between the rudder and the Elevon so that it can move freely. So now we'll apply glue. We'll apply glue along this edge here and along that edge, and then also right there, just on those surfaces. Obviously we're not gluing the Elevon to the rudder. And then we're going to put the rudder in place. It should be on the top side of the wing. This is the top side, and the rudder should be on the top side of the wing. So it will be flush with this line here and the rounded edge here towards the leading edge. And we're just going to touch it in place, push it down, and smoosh out the glue a little bit. Now I'm going to separate these and let the glue tack up a little bit. Let's push it down a little better. We're going to put a little pressure, spread out the glue. And we're going to set it aside for minimum 5 minutes, maximum 10 minutes as before, for this to tack up, and then we can reapply these. Now these had a chance to tack up, we're going to apply the rudder to the wing and push down, smoosh it down a little bit, make sure it's in good contact. Okay. And so this wing is done. Repeat the process for the left wing, and both wings will be ready to go.